The main difference with landing on an asteroid with respect to any other planetary body is the low gravity. Because these objects are so small, they have almost no gravity, so they don't pull you down. The reason we're particularly interested in landing on the surface of an asteroid is that we can use this to study the physical properties of that asteroid. Philae lander demonstrated actually how challenging it can be to land on the surface of one of these small bodies. So it didn't quite work to plan, and of course it was supposed to stay in one place when it came down. Instead it rebounded for an extremely long time and a long distance over the surface of the comet, and then became wedged in a crevasse and stayed there. The Hera mission follows on from the DART impact mission, which is our first test of planetary deflection. And the European Space Agency will then send the next spacecraft to the same asteroid to try to understand the asteroid system and better quantify what happened during the DART impact. For asteroid landers, this means that we have to go down at an incredibly slow speed, so that we don't bounce off the surface and not come back again. The almost absence of gravity at the surface of the asteroid also changes how the surfaces behave, how the materials behave. And so it's actually very difficult to predict the outcome of landing from existing theories. We have a projectile, or a lander, that we will release just as the box starts to fall. Now, the box is slowed down by these pulleys and counterweights, but the projectile is in free fall. So it will move slightly faster, and it will come down and it will touch the surface at a very low speed in low gravity, simulating what we're going to be doing in asteroid landing. If we can measure precisely how much we impact into the material, this actually gives us really important clues as to the physical properties of the asteroid itself. And so I think one of the main lessons to take away is that anytime we want to go down and touch the surface of an asteroid, we should use instruments like accelerometers or force sensors to measure that interaction. And by measuring the interactions, this is going to give us really important information about the surface properties and about the asteroids themselves. There's a field of study called in situ space resource utilization, and the idea is to investigate how we can use the resources that exist already in space for space exploration. So one example is if we think that asteroids contain some materials that could be used as propellant for spacecrafts, for example. We can go and we can use that, find a way of extracting that material, and then you basically have in-space service stations that you can fill up your gas tank and then go on and explore the solar system further. It's still very, very early days, but there are companies and space agencies that are looking into this.